So we are picking up where we left off with 7.5 day 2. Starting at the top of the back of the notes. If an equation contains two radical expressions or two terms with rational exponents, isolate one of the radicals or one of the terms. Will you get those blanks filled in? Okay, let's do some examples with that. All right, here we've got two different terms that both have rational exponents. If you would prefer to write them with fractions instead of those decimals, you can. What is 0.5 as a fraction? 1/2, and 0.25 is 1/4. So if you would prefer to write those with fractions instead of decimals, you can. All right. The rule we just wrote was to isolate one of those terms or one of those expressions. So you get to pick which one you want to get alone. In this case, they will both sort of be alone. Okay, so if I want to get this front set of parentheses by itself, what am I going to have to do? Add. If we are subtracting this whole second half, I can get rid of it by adding that whole entire thing. 3x plus 4 to the 1/4 power. But I have to do that to both sides. 0.25 is 1/4 as a fraction. We just talked about that. Now the nice thing is that the other side was 0, so that makes that addition pretty easy. So we're left with 2x plus 1 to the 1/2 power is equal to 3x plus 4 to the 1/4 power. Are we okay with that? We got one of those alone, which sort of ended up getting both of them alone. All right, if we are talking about the 1/2 power, this is when it might be useful to actually have it written as 1/2 instead of 0.5. Who remembers how we got rid of that fractional exponent? The reciprocal. We raise both sides to the reciprocal power. What's the reciprocal power? 2/1. Okay, this is when the fractions become handier than the decimals. We don't really think about decimals as having reciprocals, but fractions do. Okay, so we raise both sides to the second power. When we do that, we are left with 2x plus 1 equals, what's the new exponent going to be on 3x plus 4? 1/2. 0.25 or 1/4 times 2 would make it into 1/2. Does that make sense?
Why is that 0.25 written as 0.25?
Because it's the same as 1/4. If you prefer the fraction, you can write it 1/4. It's up to you. Do you prefer the 1/4? Are we okay so far? Jacob, do you have a question?
So did you subtract 1/4 minus 2 to get 1?
I took 1/4 times 2. Because that would give me 2/4, which reduces to 1/2. If we take an exponent and raise it to another exponent, we multiply them. Any other questions? Does it look like we're ready to get x alone yet? Why not? We still got those parentheses with a fraction as an exponent. So what do you think we have to do to both sides now? Not multiply by 2. Square both sides. if we still have a fraction as an exponent, we kind of have to loop back and do that same step over. We're going to raise both sides to the second power, or square both sides. We have to get rid of all the fraction exponents the whole way through. Okay, so now on the right-hand side, what is that going to leave me with? The right-hand side, 3x plus 4. Okay, on the left-hand side, what do we have to do? We have to expand it out.
Oh,
2x plus 1 times 2x plus 1. And then we have to double distribute.
Can I move the answer of that?
Sure.
4x squared
4x squared
plus 4x plus 1.
plus 4x plus 1 sounds beautiful. Do we have questions so far? This process is a little different. Okay. Now we've got a quadratic equation. We need it to be set equal to 0. So remember, I recommend that whatever side the x squared is on, you kind of leave that side alone and make the other side be 0. So how am I going to make the other side be 0? Subtract 3x and subtract 4. Subtract 3x, subtract 4. Okay, when I do that, I'm going to carry it up here. 4x squared. What else is left? Plus 1x, good. Minus 3 equals 0. All right, then our next step is to factor it. If we have a leading coefficient that is not 1, what method do we have to use? Bottoms up. To start bottoms up, we multiply 4 times negative 3, and we get negative 12. We are looking for the factors of negative 12 that add up to positive 1. Or remember, if this is a negative, we think about the difference being 1.
4 and 3, right?
Which one's positive, which one's negative?
Negative 3.
4 is positive, the 3 is negative. We go to our parentheses. We would have x plus the 4, x minus the 3. Why did I leave a little space under these? We have to divide them both by the leading coefficient, which is 4. Okay, which one of these simplifies? First one, 4 over 4 is? Does the other one simplify? No, so bottoms up. We end up with 4x minus 3. Now we need both of those to be set equal to 0. X plus 1 equals 0. 4x minus 3 equals 0. Let's be careful when we do these. On the first one, what are we going to get for x? X equals negative 1. And on the second one? 3/4. We add the 3, and then we divide by 4. We still have to check these. So I'm going to rewrite my answers all the way up here at the top so that I can keep track of those. We had x equals negative 1, x equals 3/4. Now, do we have any questions about the solving step before we do the checking step? Are we sure? The solving step was awfully long. It's mostly review, you're correct. The only differences being that we've got the decimal / fraction exponents, and also that we had to raise it to the second power twice to get rid of them completely. Okay, if there aren't questions about it, then I'm going to take all of that hard work away so that we can check these answers and see if either of them are extraneous. Now the other thing I'm going to do when I write this is I'm going to write them in radical form. So we already talked about how the 0.5 power would be considered 1/2, and the 0.25 power is considered a 1/4. But what if I wanted to write those with radicals instead? The first one would be what kind of a radical? What kind of root? The 1/2 power? Well, what's my index? 2. So if an index is 2, what kind of root is it? Square root. So I'm going to rewrite this as the square root of 2x plus 1 minus, if it's to the 1/4 power, it would be a 4 would be the index, so it's a 4th root of 3x plus 4. Okay. Rewrote them with radicals. Now I need to plug in. What do you want to check first? That is not one of our answers. Which one do we want to check first?
-1.
Okay, let's check -1 first. So we've got 2 times -1 plus 1 minus the 4th root of 3 times -1 plus 4. We're trying to see if that comes out to equal 0. What is 2 times -1? -2. What if we add 1 to that? Whoa.
1.
-1. So we have the square root of -1 minus the 4th root. What is 3 times -1?
-3.
-3 plus 4
1.
is 1. Can we take the square root of -1? We would end up with an I. Do you think an I is going to be very useful to us right now? No. This would leave us with I minus, what's the 4th root of 1? 1. Does I minus 1 equal 0? No. Okay, so this is not going to work. If you end up trying to check it and you get an I, things are not going to go well. Unless, of course, the other one also gives you an I, but that would just be very strange. Okay, but then this situation for sure, that does not check out. So what would we say about that solution?
No.
We'd call it extraneous. So x equals -1 is an extraneous solution. That does not tell us anything about our other solution. So we need to start this process over again and check the other solution. So let me make a little space over here to do that. Again, I'm going to substitute it in with the square roots. So we have 2 times 3/4 plus 1 minus the 4th root of 3 times 3/4 plus 4 equals 0. This is not going to be extremely pretty to check, but we are going to do our best. All right, if we take 2 times 3/4, what do we get? 2 times 3/4. Let's just leave it as a fraction. 2/1 times 3/4. 3/2, okay. So 3/2, and then we'll add a 1 to that in just a minute. What about 3 times 3/4? 9/4. Okay, and we're adding 4 to that. Okay, so we have 3/2 plus 1. 5/2. Square root of 5 over 2 minus, I have a fourth root of, what's 9/4 plus 4? 25 over 4. All right. Now, this is where a calculator might come in handy.
Why do you say white?
Because there's a way to see that whether or not this works out without a calculator. But if you want to make your life a little bit easier, in your calculator, take the square root of 5 over 2, or the square root of 2.5, and give it to me as a decimal to a few decimal places. What would it be?
1.5.
A few decimal places. What is it?
1.58.
Whoa. I need one person to raise their hand and speak clearly and at a pace that I might actually be able to write at. Charles?
1.58113.
Okay, I'll leave it at 5.811. Sorry, 0.5811. Are we all in agreement with that? Okay. Then let's also take the fourth root of 25 over 4 and give me that to a couple decimal places. Probably the same amount of decimal places would be good. Charles?
It's the same number.
It's the same number. So if I subtract those, would it come out to equal 0? Yes, it would. So is this one extraneous? No, that one is a legitimate answer. So we would not call it extraneous. Okay, this one's nicer because, first of all, there are not decimals or fractions that we have to deal with because for some reason those terrify us. Also, what do we notice about these roots? They're both square roots, which makes our life a little bit easier. We still need to isolate one of them first. So again, I would kind of recommend getting this front one alone on that side. What would we have to do? Okay, we need to add the other square root over. So that leaves us with the square root of 3x plus 2 equals the square root of 2x plus 7. We okay with that? No? Not okay?
No.
Kind of okay? All we did was add something to both sides. Now what do you think we need to do?
Square.
Square both sides. We need to get rid of those radicals. So we square both sides. Then both of our radicals are going to go away. So what are we left with?
3x plus 2 equals 2x.
Beautiful. What's nice about this?
There's no.
Why is this nicer to solve than those last ones? You can just start subtracting things, moving things around to get x alone. This is not a quadratic, so we do not have to worry about getting it set equal to 0 and factoring. There's not an x squared in it. We don't have to do all that. So we just want to get x by itself. What do you want to do to make that happen? Subtract 2x and also subtract the 2. Okay, so we subtract 2 from both sides, subtract 2x from both sides. What does that leave us with? X equals 5. We only get one answer this time, but we still need to check it. So we'll go to the original problem. We've got the square root of 3 times 5 plus 2 minus the square root of 2 times 5 plus 7 We're trying to see if that comes out to equal 0. So I just plugged the 5 into both of the x's. So let's start simplifying under our radicals. 3 times 5 plus 2 minus the square root of 2 times 5 plus 7. Do we need to turn these into decimals? Not really, because the square root of 17 minus the square root of 17 is going to equal 0. Is this extraneous? No. So we got one answer and it worked out just fine. A little bit easier than that first one.
Are we ever have a note thing?
If we ever have time for one, yes. These snow days keep messing us up.
We should have time for this one.
Okay, so we could start off by moving the second set of parentheses over to the other side by doing what? Adding it. I also want to rewrite this in radical form. No, I don't. Never mind. You could rewrite it in radical form. I always like things in radical form, but we don't need to do it. So we'll leave it in fraction exponent form for now. Okay. We got both of them on their own side, so they're not together anymore. What's the next thing we need to do? Okay, so we need to get rid of our fractional exponents, right?
Reciprocal.
So the reciprocal, which Lanaya said is 3 over 2, if we're focusing on this left side. 3 over 2. Is it going to totally trip anybody up if I said instead I want to focus on the right side? It's going to make your life easier, I promise. If we were to instead focus on the right side, what reciprocal would we need? 3. If we do it this way, it's going to get rid of both your fractions at the same time. If we were to do it the other way, we would still have a fraction left, which you could deal with, but I'd rather get rid of them both at the same time. Devin?
Why would you focus on the right? It's 3 over 2, same thing. Well, you still must on 3.
Because the individual six on YouTube.
Yes.
2/3 equals 3. What? How do you,
I am unsure if you were asking a question or trying to tell me important information.
no, how does that take it off?
Oh, so when we multiply these, right? Multiply straight across the top, straight across the bottom, and then simplify.
Alright,
So 6 over 3 gives us,
3.
whoa,
I mean,
2. Okay, so the fraction's gone. And on the other side, what are we left with? 9x plus 1. We'd have a first power. We don't have to write the first power. Okay, this problem's not quite as nice as the last one, however, because what are we going to have to do on the left? Expand it, double distribute. What do we get when we multiply out x plus 1 times x plus 1? Good. X squared plus 2x plus 1 equals that 9x plus 1. We have a quadratic, which means we need it set equal to 0. What should I do? Subtract 9x and subtract 1. Okay, that's going to leave me with what on the left side? X squared minus 7x equals 0. Now, x squared minus 7x equals 0 does not look like the other quadratics we've had so far. So we need to think back to our factoring process. What's the first thing we're supposed to check for when we factor?
GCF.
A GCF. Do we have a GCF?
No.
Whoa.
Oh, X.
We sure do, and it is an X. So when I go to factor it, which I'll do up here, I would have X outside the parentheses because that's my GCF. And then inside the parentheses, what would I have left over? X minus 7. Good. Now, when we were solving these last semester, this is a part that some people were not so great about remembering what to do. If it's a quadratic, we should have 2 answers. 2 of them. So 2 different things need to get set equal to 0. What are they?
X equals 0 and 7. No, wait, no. X equals 0 and then X minus 7.
Good. X equals 0 and X minus 7 equals 0. That X that was the GCF that we should not have just left off, we should have written it, that counts as a factor and it gets set equal to 0. The nice part about it is then there's nothing to do to solve that. But we have to solve the other one. X equals 7. So my 2 possible answers are X equals 0 and X equals 7. What do I still need to do? Check. Do we have questions about the solving part of this before we do the checking part of this? We're sure? Okay, then I'm going to erase it. Erasing. If you notice from the beginning, this is just a side note of why I switched up how we were doing it. Notice that both of these have the same denominator, right? That's why I wanted to raise them both to that power. Because I knew if they had the same denominator, if we raise them both to the 3rd power, it would get rid of the denominator on both of them. Okay, so if you have the same denominator, you can raise it to that power to get rid of both of the fractions. Okay, if you had done the 3 halves, that's fine. You would have then just had to go back and do another step where you squared both sides to get rid of the 1/2 power that you would have had over here. Okay, and you'd end up with the same thing. Does that make sense? We just eliminated a step. Okay, we cannot, however, eliminate our simplifying step. So let's plug in 0 first. City is already telling us it does not work. Are you sure?
It does, you silly goose.
Did you say it does or doesn't?
It does work.
Yes.
If we plug in a 0, 0 plus 1 is?
1.
1. Okay, and 9 times 0 is?
0.
Plus 1 is? Okay. What is 1 to the 2/3 power?
I got this. Where's my calculator at?
You don't need a calculator for this.
It's just 1, isn't it?
It's just 1. 1 to the 1/3 power is also 1. What is 1 minus 1? Is this one extraneous? Is it extraneous? No, it's just a legitimate solution. Questions about that one? Are we sure? Have I lost some of you?
Some are sleeping and still sleeping.
Okay, let's check the other one. Those of you that are still with me. We're going to plug in. Nobody knows. I lost everybody. What am I plugging in now? 7. We're plugging a 7 in for X. Okay. 9 times 7 plus 1 to the 1/3. Okay. Plugged in a 7. 7 plus 1 is 8. 7 plus 1 is 8. So we have 8 to the 2/3 power. I will recommend we change that to a radical next. What about 9 times 7? 63 plus 1. 64. Okay, you either need to know how to put fractional exponents into your calculator,
I do.
or you need to be able to convert it to radical form.
Can I show the class how to do this?
No.
No, we don't have time for show and tell.
64.
It's 4.
Come on, Jacob.
The cube root, if you need to turn it into a radical, much like with the one we just talked about, this would be the cube root of 8 squared. And this would be the cube root of 64. Okay, 8 squared is what? 64. Now, it might be helpful for some people to see this simplified all the way out, but do we need to take the cube root of both of those? No. If you take something and you subtract it from itself, what are you going to get? 0. Okay, so if you want to take the cube root of 64, you can do that. It is just not necessary. Do we understand why? Take something and subtract it from itself, you're going to end up with 0 either way. So are either of those extraneous?
No.
No, they both worked out to be valid solutions. So we've got the same denominator and they are already separated from each other. So what is our first step going to be? Not times by 3.
Oh, wait.
Multiplying by 3 implies that you want me to put a 3 out in the front of both of those.
Exponent.
Use 3 as an exponent. Raise both sides to the 3rd power. Now I understand that might have been your intention the whole time. However, you need to tell it to me correctly. Okay? If we cube both sides, what are we left with on the left side? 4x plus 3 squared. Okay, remember those 3's will reduce or cancel each other out, but that does still leave us with a 2 as an exponent. And on the other side, what do we got? 16x plus 44. Okay. Devin?
I'll just put 2 to 3. That's 1, 3.
All right, we need to square 4x plus 3. Anybody get it yet? 16x squared plus 12x plus another 12x. 12x plus 12x would give us 24x. And then on the end we would have, we'd have what? Plus 9. Positive 3 plus 9. You guys are making me a little nervous with that squaring a binomial. Do we need to see it all written out?
No, what's,
Are we sure?
could you explain how to, not write it out, but what's the easy way of looking at that?
Square the first term. That's how we got 16x squared. Square the back term. That's how we got 9. Twice the product. So multiply the front and the back and then times 2. So 4x times 3 is 12x times 2 is 24x. Square the front, square the back, double the middle is kind of what the shorthand way of saying it is. Now we have a quadratic, which means we need it to be set equal to 0. How do we make that happen? Subtract 16x and subtract 44. Okay, what does that leave us with?
16x squared plus 8x or minus 35.
35? Okay. This one is not pretty. Because we do not have a leading coefficient of 1, right? We don't just have an x squared in the front. So we had been doing what method? Bottoms up. But if we do bottoms up here, what are we going to end up with?
Big number.
16 times negative 35. Now, I'm not saying we can't do bottoms up here. I'm just saying it's going to be kind of time consuming because I don't think 16 times 35 is on our factor sheet. So what do you think I'm going to recommend? That formula, the quadratic formula. No, that's the Pythagorean theorem. I'm going to recommend that we use negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So yes, that means we need our a, b, and c. What are a, b, and c?
A 16, B 8, C negative 3.
Okay. Let's start plugging things in. X equals, what is the opposite of 8?
Negative 8.
Negative 8 plus or minus the square root of, what is b squared? 64 minus 4 times a times c. Just plugging those in. Negative 4, 16, negative 35. All divided by, what is 2 times a? 32. All right, underneath that radical, we need to take negative 4 times 16 times negative 35. What do we get?
Some big number.
2,200 what? 40. Okay, so that means we're going to have 64 plus 2,240 because we ended up with two negatives. Negative times a negative came out positive.
30. Whoa. Nope.
Do we have questions about that step? Now we need to add 64 to that. So we've got negative 8 plus or minus the square root of 2,304. What's the square root of 2,304? 28? 48. That sounds better. So we have negative 8 plus or minus 48 over 32. But when the radical went away, do we remember how we handled that?
8. 4.
So we could divide all of those by 8, sure. If we divide them all by 8, what do we get? Over
4.
just a 4 on the bottom. Okay. We're still not done all the way though. Because if we don't have a radical, we can split this into two problems. So I'm going to drag it back over here. We could have done all of this with bottoms up. We could have. I think it just would have taken us longer to figure out what our factors would have been. So we can split up the plus minus. What is negative 1 plus 6? 5. So we end up with 5 over 4. What about negative 1 minus 6? Negative 7 over 4. So those end up being our two x's. 5/4 and negative 7/4. What do we still have to do? Check it.
Get another paper.
All right, we'll check 5/4 first. So we've got 4 times 5/4 plus 3 raised to the 2/3 equals 16 times 5/4 plus 44 raised to the 1/3. Now this is nice because 4 times 5/4, what happens with those 4s? Cancel out. We're left with 5 plus 3, which is 8. So we have 8 to the 2/3 equals 16, and the 4 can Simplify to a 4. So we have 4 times 5, which is 20. 20 plus 64 is, sorry, 20 plus 44 is 64. Kind of gave it away. Then if we do that same trick that we did on the last one, when we switch these, what do you mean it's not going to work? If I switch these into radical form, I have 8 squared, the cube root of that. What is 8 squared? Do I need to take the cube root of those? No, because I can already tell that it works. They are equal to each other. So that means 5/4 is or is not extraneous? Is not. 5/4 is not extraneous. Okay, let's go back and do negative 7/4. So let's see if I can just change this a little bit. These are now negative. All right, so again, we do all of this. We've got the 4's canceling out, so we've got negative 7 plus 3. What's negative 7 plus 3? Negative 4. So we have negative 4 to the 2/3. Okay, again, the 16 and the 4 cross reduce, so we've got 4 times negative 7. Negative 28 plus 44. Nobody knows. Negative 28 plus 44. 16 to the 1/3. If we convert these to being radicals, cube root of negative 4 squared and the cube root of 16, what's negative 4 squared? 16. So, do we have any extraneous solutions? No, we don't. Those are both valid.